Which of the following molecules or ions would be polar? Okay, so we're talking about polarity of molecules, and we know polarity is determined by the Lewis structure and the molecular shape of molecules. So let's do each of them individually. Ammonium ion. Nitrogen is in group 5, hydrogen is in group 1, 4 hydrogen, so that's the total valence electron, -1 for the positive charge because that's losing 1 electron, so 8 electrons, and that means 4 pairs in the Lewis structure. So nitrogen in the center, hydrogen on surrounding, 1, 2, 3, 4. 4 pairs used. Hydrogen only needs 2 electrons for its octet, and nitrogen got its octet. No rearrangement. We're good. And with this electron configuration, and with 4 regions of electron density, we're talking about tetrahedral geometry, and since there's no lone pairs, it's tetrahedral shape as well. So geometry and shape. And because tetrahedral is a very symmetrical structure and all 4 non-central atoms are the same hydrogen, so this is clearly a non-polar particle here. Beryllium chloride. B is in group 2. Chlorine is in group 7. Got 2 of them. Total of 16 valence electrons. Of course, 8 pairs. B, Cl, 1, 2, non-central atom octet. That's 8 pairs used. And no need to move things over because beryllium, Be, is in one of our rules as something that only requires 4 electrons in its octet. So with this setup, you can see that 2 regions of electron density, it's linear. Again, since both of there's no lone pairs, so it's linear geometry and linear shape. With both ends having chlorine atoms, this is a non-polar molecule. H2S. 1 times 2 times plus 6, that's 8 electrons. And that's 4 pairs. Hydrogen can't be the central atom, so sulfur gotta be the one. There's 2 pairs used. 2 pairs on the other 2 pairs, put it on the central atom, and now we got an octet for sulfur as well. And 4 regions of electron density leads to tetrahedral geometry. But with 2 lone pairs in the tetrahedral geometry. Remember, lone pairs, when it comes to shape, you can't see them. They're invisible, and that makes this a bend shape. And bend shape always gave us polar molecules. Although there's no need to continue because the multiple choice question, well, let's finish BF3 anyway. That's group 3. Group group 7, 3 of them, 24 electrons, 12 pairs. Boron in the middle, fluorine on the side. Octets for fluorine, and that's 12 pairs. And boron, again, is one of our irregular octets. Boron only needs 6. And this would be good. And this would give us a trigonal planar geometry with 3 regions of electron density. And again, because there's no lone pairs, its shape would be trigonal planar as well. And trigonal planar shape with 3 non-central atoms being the same would always give us a non-polar molecule, and that's what we expected. So the correct answer here is C, H2S. This would be a polar molecule.